an IH report on, and oh, doesn't matter if there's a pop-up. Whatever. Um, so I found it interesting seeing that there's an IH article on this because nanomaterials, I think, is a pretty new occurrence. And so, what is a nanomaterial? What is nanotechnology? It's used in a lot of industries, pharmaceuticals, textiles, even, of course, electronics. And so, there we go. So, what is nanotechnology? Nanotechnology is comprised of nanomaterials, and a nanomaterial, maybe what comes to mind are carbon nanotubes. Carbon nanotube is basically just graphene, a single ply of atoms basically rolled up into a tube. And so you can find these in industries making like batteries, aerospace materials, so forth. And what's interesting about nanomaterials is that it's cancerous if you inhale it. And surprise. Um, so it causes actually a few mechanisms of action, and we can take advantage of that to indicate various biomarkers that occur when we inhale these nanoparticles to see what exposure looks like when relating it to the particle concentration in the air of the factory we're working in. And so some of the mechanisms of action include genotoxicity, inflammation, and oxidative stress. Oxidative stress occurs when you inhale the particle and your body produces free radicals which attack your cells, causing oxidative damage and antioxidant depletion, which is not good. And then nanomaterials are small enough so it can cross membranes in your body, including your blood-brain barrier, which is what's pictured there, and including your lung epithelium. It can cause chronic inflammation and cause early on stage pulmonary fibrosis. Another interesting thing is when nanomaterials enter your body doesn't know whether or not what it is. So it'll detect it as either a bacteria or a virus, and it will act accordingly. And it'll produce these proteins. That's a cytokinetic reaction, if you're familiar with the immune system. So that's interleukin and tumor necrosis factor. Those are just your typical cytokinetic reactions. They're signaling proteins for your innate immune system. Oops. Why do we care about this? I mentioned it causes cancer. Here's the various selected nanomaterials there. Black carbon, carbon nanotubes, a lot of oxides, iron oxides, silicon dioxide. Calcium carbonate is nanomaterial as well. And this study is super important because we have super limited health effect information. This is like a new and upcoming topic, and so it's not fully understood. And this article actually pretty much journal clubbed other articles, took a big poo-poo on other articles, and they were pretty disappointed with how other research projects were experimental oriented or cross-sectional, and they didn't like that. So they decided they wanted to instill and start this cohort I'll talk about in a second here. A prospective cohort with 141 people, which is far more than any other research project undergoing nanotechnology exposure. And this happened, it was an international cohort in Switzerland, Spain, and Italy, where there were 5 companies that were used as the variables or exposed groups, 2 companies used as the unexposed groups. So the way they did this was they contacted these companies that were working with nanomaterials, particularly research and development, so like universities, and they filled out questionnaires. The companies filled out questionnaires depicting what they were being exposed to, what nanoparticles they were working with. And a team from Nano Explorer, the cohort, had an occupational hygienist come in and do a survey or sampling, use electron microscopy and whatnot to select particle sizes to verify what was on the questionnaire was correct. And then they started with sampling. And the way they sampled was they took biological sampling as well as particle count sampling. So that includes lung deposited surface area and particle number concentration. LDSA, or lung deposited surface area, is the most indicative of how the impact of the nanomaterials will be on your lungs. So that is pretty much how toxic it will be. And particle number concentration, that's just your typical disk mini. It's a particle reader. You just read it right on the display. And relevant biomarkers, they had a bag there to measure your oxidative potential. And they also took your exhaled breath, condensate, and urine samples. And all of these biological samples is what provided data for the biomarkers. Here's just a quick data graph showing not exactly the results yet, just showing the non-exposed and the exposed groups, the biomarkers that they collected, the biological samples. So with the exhaled air, they were looking for oxidative potential of exhaled air. With the EBC, exhaled breath condensate, they found that the most important because it is the most indicative of early stage pulmonary fibrosis. And then urine was predominantly used as a correction factor for their graphs or a normalization. On to the results. They used linear regression, comparing the particle that they found in the air as well as the biomarkers. And they found that there was a positive dose relationship between the inflammation biomarkers with the particle count as well as the lung deposited surface area. There was a negative dose relationship between the particle number count and the total antioxidant power. That's what I was talking about with the oxidative stress. Yep. So that essentially says occupational exposure to these nanoparticles does have a negative effect on your oxidative balance and your innate immunity. I selected from some of the tables the most important biomarkers that show the greatest effect. And also it lists like the most common materials that were used: titanium dioxide, silicon dioxide, carbon nanotubes, calcium carbonate, black carbon. And those looked like they had the greatest impact, the highest significance. Something cool I found about this project was that it created this DAG chart. So with biomarkers, there's so many variables going into it, and you have to account for all that. And so they use this DAG diagram to adjust their sensitivity of the data when correlating their nanoparticle exposure to their biomarkers, because everything affects your immune system, right? So that I found pretty strong in their cases. So another more strengths is, I mentioned this is the first extensive study on dose response, the relationship between nanomaterials and your immune system. And coming with that, you're going to receive novel immune responses indicating what's happening to your body. So discovering some of the different cytokinetic responses is linked with some nanomaterial exposure is pretty fascinating. And weaknesses. Exhaled breath condensate is super tricky. You're breathing into a bag, and there's a lot of stuff going on in that bag. So what you're looking for your biomarkers is super dilute. There's a whole lot going on in there, so your limit of quantification is super low. And so you might get a lot of readings showing null, there's nothing there. So you have to have super sensitive machinery. And honestly, that can only be improved with time as technology progresses. And biomarkers in general are tricky, sensitivity issues and whatnot. So have you guys heard of nanomaterials or delved into it? Do you think we should pay more attention? That's my discussion question. That's it.
Yeah. So part of the participant sections talked about how a lot of the people in the exposure group had a lot more tobacco smoking. They smoked a lot more often. Do you know if they adjusted for that?
They did, yeah.
Okay.
So that's the diagram. I found that pretty interesting because, I mean, when you're on the floor, you notice like, you know, people from the office and operators working on the field, they do tend to have like poor health, as you noticed, poorer health. And so, yeah, they did take account for that. They also noted that women are more likely to be in the admin position as opposed to out on the field, and they accounted for that as well.
Did they compare the exposure group and then stratify that with smokers and non-smokers to see what the effect would be? Because like obviously a lot of the things they're testing is in the lungs.
Right.
And that's where smoking is going to affect them the most. So I'd be interested to see if those people that were smokers, if they were like the driving force in the data they found versus.
Yeah, so they did find, when they adjusted for the non-smoking, they did find that there was less significance. Yeah, so that's like the early on tables, like 3 through 5 or something, were not adjusted for the confounders and whatnot. And then 6 through 7 were adjusted, and they found a lot less significance in their data. That's why you didn't see a whole lot of there's more cytokinetic response as opposed to, let's see, it was yeah, they just saw more inflammatory proteins being produced.
Yeah. I might have missed it, but was there anything more about the difference in work schedule with the exposure groups? So I know it showed that like some of the factories or sites or whatever held like a pretty different schedule, like a 2-day versus a 4-day or something. Should they
Yeah, so
adjust that, or?
they had a harmonized method, and that was basically just sample them at the beginning of the work week, and biological sampling would take place at the beginning of the work week and at the end of 4 days of working, and particle count would happen continuously throughout those 4 days. Yeah, so it's like pretty standard.
But did they say some of the sites only work 2-day schedules, or it was a different, like it seemed like it was a different exposure length or something?
Probably. I mean, if they were exposed differently, they were exposed differently. I don't know.
In terms of industrial hygiene applications, are there any industries specifically that, from the data that you got here, should be size selecting for nanoparticles if they can?
Yeah, that's actually huge. So one thing that they mentioned about previous articles is that it's super hard to differentiate all these particle sizes and really determine whether what you're being exposed is that particular nanomaterial. So what this cohort did was they selected using electron microscopy to see these different types of nanomaterials, and they were able to differentiate accordingly.
So when we say that they were able to differentiate size, is it like through the exhaled air itself, like they would see size select, or what exactly are they size selecting?
The different nanomaterials, like all the carbon nanotubes and the iron oxides and whatnot. Yeah.
In the exhaled air that's coming, so they're biological.
Exactly. So that, as well as urine samples and exhaled air condensate. Yeah. So exhaled air and exhaled air condensate are two different things that are. Yeah.
What kind of industries does
Research and development.
that's
That's mainly it. You obviously
pretty broad.
Technology. Yeah. Technology. I said aerospace materials, batteries, even stuff like that. Textiles.
like if you maybe like industrial work or kind of fabrication, like what percentage of those employees are being exposed to, or those workers are being exposed to nano? Is it a very big problem or is it? Small problem?
That's a good question. What brutal. That's kind of my discussion question too. Should we worry about this? How big is this? I don't know. Have you heard of it? Nanomaterials?
Materials?
Yeah?
Yeah.
Okay. Do you know how big it is? How important?
No, I have no idea. I do imagine it's probably a lot of aerospace and probably med tech.
Mhm.
Do you know if any of the workers were wearing any sort of PPE?
Yes. So they accounted for that. They either showed whether or not they were wearing PPE, had access to PPE, but barely used it, or never used it. They didn't specify that.
An issue. So nanoparticles penetrate masks. Kinds of masks, so what's gonna get filtered out? Is the rhetorical questions, because there's no answer, right?
Well, I mean, if the PPE type is consistent within site, they did account for that in the statistical model, like they clustered by site, so that shouldn't affect like the inference.
There's PPE that would be completely useless, not much different than the COVID situation.
And what they talked about was during COVID, when they had masks and they tried to separate that out and that was a short,
They're completely useless for nanoparticles.
thing.
So they had 43 unexposed and 98 exposed, so there's basic epidemiology questions second year should know. What would you prefer to see? More cases, more controls, which more exposed, much unexposed?
More controls.
Or unexposed? You only have 43, so it's less than half, right? So that's a huge problem. Do anybody know why? Why would you want more non-exposed? It has to do with you typically have more heterogeneity in the unexposed than the exposed. Exposed groups tend to be more heterogeneous, homogeneous, I'm sorry. And so you generally want roughly at least 2 times as many. So we have less than 1/4 of what we need. Now, are there any variables there that are markedly different? There must be, or I wouldn't think, but anybody catch that?
It said that gender was a kind of big difference, where there's almost 50 to 20, I think. 50% of the non-exposed was women, and then 20%, I think, of the exposed group.
So there is definitely different with this concern. It's one even bigger than that. What's down, halfway down. Medications. We're at table 2, I should have. See them?
3 versus 18.
Massive difference,
Oh, wow.
right? 70% versus 20. What on earth? You know, when things are that different, can you adjust for them adequately, or you're gonna end up with residual confounding going on? You'll suggest you're gonna have problems.
Are you talking about table 2, where it just had like 3 different biomark or samples and the biomarkers that follow?
Just looking at the unexposed and exposed.
Oh, yeah.
I think that's supposed to be a 7%, not a 70. Based off the 3.
Okay.
Which changes it, but not, it's still 7 to 18.
Vaccination 2043, there's a bunch of differences anyway in this table, which should raise a lot of comparability of populations. See that kind of thing, you always have to just wonder about confounding, because no matter what you do with the modeling, you can only adjust for that which you put in the model. Not saying it's fatal flaw, I'm just saying, not quite optimal, so room
Yeah,
for
they-
further improvement.
You don't like that there's a difference between the.
Not that much difference.
Not that much.
I've got a question online from Michael McBain. He's asking, the increased heterogeneity from having a small unexposed group would result in decreased power? That might have been directed to you, Kurt.
Not so much a power problem as it is, because you've got samples that detect effects. But the problem is your problem with confounded residual confounding remains no matter what, because these groups are so different. And my understanding is I'm wearing articles, by the way. I have a one of these wrinkleless shirts, just so you know.
We'd be wearing PPE?
Yeah. Exactly. I don't know. My wife doesn't like to iron. Neither do I.
Cool. All right, thanks, guys.
Let's move left if you want second. Yes.
Hello, everybody. Can you hear me? So I'm Lucas. I'm a second year IH student here to talk to you guys about hearing loss in Grand Prix motorcyclists. Pretty interesting study, I think. I think it's got some good applications that we can use as future researchers or those of us who need to write theses, do dissertations. I think there are some important things that we can take from this article. Also, both of the last time, or this time and last time that I've done presentations, both of the presentations before me have been super high level. So I'm surrounded by lots of smart people. I think you guys will be a big help in interpreting some of the problems that I saw with this study. Interested to hear your guys' thoughts. So the purpose of this study was to assess the potential risk of wind noise to professional motorcyclist hearing. At the beginning of the article in the introduction, it talks about a relationship that they found with noise levels and speed in motorcyclists. So you see at the bottom level, it starts like at 40 miles an hour, it starts pretty low, but then it increases pretty rapidly up to 150 miles per hour that motorcyclists typically go. Wind speeds are associated with like 120 decibels. And for those of you that don't know, decibels are actually on a logarithmic scale. So for every 3 decibels that you increase, you're actually doubling in the sound pressure that's coming from them. This study was a cross-sectional study, and with its purpose to accomplish that, the approach that they took was to do a prevalence study. They tried to measure prevalence of noise-induced hearing loss among these Grand Prix motorcyclists. They met them at an event. There were 100 plus riders there. They recruited almost 50 of them, or it was about 50 of them. And they measured their prevalence, and we'll get into the methods here in a second. So their hypotheses, really, there's just one, that Grand Prix motorcyclists, these professionals, are going to experience noise-induced hearing loss according to audiometric testing. That's what they're trying to get across. So we have our 50 motorcyclists out of the 103 that were registered in this race. 44 of them wound up being included in the study. There were some exclusions. An important back note here is there is a difference between sensory neural hearing loss and conductive hearing loss. The one that we're looking at here is the hearing loss that occurs that's permanent. Sensory neural hearing loss. Conductive hearing loss is typically caused by blockages in your ear. So there were some exclusions for that reason in the population they were studying, as well as there were individuals who had previous experience with hearing loss, so they didn't qualify for the study, just to make sure that they could match them with their control group. When the methods went into two parts at this point, they were given an interview. During the interview, they were asked about their previous noise exposure. They were asked about earplug use and just basic ear pathology. Then the researchers used an audiogram that they tested each of the individuals. Interestingly enough, they were all, or the site where they were doing the research was close to an airport, and there are really stringent rules around audiograms. You have to make sure that there isn't outside noise that could be affecting what the individual is hearing. So they made sure that the times that they were testing these individuals, there weren't planes flying overhead that might be disrupting the noise that the individuals might hear. And to that point, I think these are pretty solid methods to research whether or not there is hearing loss in this population. Then we get to the statistical methods. So they compared their audiometric data that they gathered on these individuals with a control group. Since all 44 of the riders were males that were included in the study, that's who they were comparing them with, was males at around 30 years old, because the median age of this population was 28 years old. So they were comparing it with a reasonable population, and they matched them by age, sex, and then the controls were non-noise exposed individuals. And riders with, like I said earlier, if they had conductive hearing loss, which that's what we were talking about earlier, caused by blockages typically, and these audiograms will actually measure that, whether or not the hearing loss is coming from conductive hearing loss, sensory neural hearing loss. So they, if the individuals had more than 10 decibels of conductive hearing loss, they were excluded from the study. And then they used the student's t-test just to pull out whether or not there was a statistical significance in the difference between your control population of the 30-year-old non-noise exposed males and your riders in this population. And then they found some results that I don't think many of us would be too surprised to hear. There was a high frequency dip. So audiograms, they are measuring hearing loss in the range that humans typically are hearing. So the higher ranges of, or the higher frequencies, that's where they saw their dip. I'd draw your attention to figure 3. It's just on, it says page 36, but it's just on the other side of the first page. They found the dip kind of in the higher frequencies, which that's actually pretty standard among humans. We tend to lose our higher frequency hearing before we lose the lower frequencies. So if you look there at around the 2000, in between 2000 and 4000, so you're like 3000 range down to 4000, which they're measuring at the 4000 and the 6000 after that and the 8000. That's where you see the dip for the most part. And you can see on that figure, the controls are the darker lines, and all 3 of them are higher up than your white lines, which are the group that we're looking at here. And that high frequency dip that we saw was found in 27 of the riders, 61% of them. And as compared to the control group, they had significantly different results at all frequencies, with a p-value of less than 0.001. So there's a high level of confidence here, according to our t-test, that we can say that they probably have noise-induced hearing loss at a higher rate than our control population. 17, beyond the results of the audiogram, as I said, it was a two-part methodology here where we had our audiometric testing, but we also had the interview that they were doing. So 17 or 39% of the riders wore earplugs consistently. And then 9 or 20% of the riders used them for more than half of their careers. Unfortunately, they mentioned in their results that because of the low number of individuals who were wearing earplugs, they weren't able to include that in the analysis. So that's a shame, and probably a limitation on the study, but not for the results that they were hoping to get, just for added information for researchers. So I think that this study does have a few strengths that we should recognize. They mentioned at the beginning of the study, they had not found any previous research that had looked at this group of people. And I always think that's interesting, because it means researchers went out of their way and thought about a group that maybe has been overlooked in the past. I think there's something to be said for us as researchers to consider groups that maybe we haven't looked at before, whether it be at work or if you're looking at a study population, if you're a researcher. They did use valid statistical and methods of testing noise-induced hearing loss in individuals for the Grand Prix riders. So I think that's strength. They counted for the airport that was nearby while they were performing. The audiometric testing goes into the valid methodology that they were using before. And they used matching with their statistical analyses. They used matched controls, which I think is really important in this case. If you can match to age, sex, and make sure your controls are actually controls, that will go a long way at making sure your results are valid. It will eliminate some bias from it. There are also some weaknesses that I think we need to recognize as researchers. The study does not establish temporality, so we're just doing a cross-sectional study here. We don't know what would be causing the noise-induced hearing loss in these individuals, though we might assume, and what the researchers are thinking is that it probably is due to the sport that they're involved in. We aren't able to say that with any level of confidence according to the methods that we used here. And then another weakness, interviews. The data from interviews are dependent on the responses rather than observed data. So there are all sorts of problems that, for those of you that have taken OCAP, you'll talk about them a lot. You've got recall bias that can cause issues. Just varying responses or interviewer questions, how they are actually prodding the interviewees for what they're trying to get to. So there's some problems there that observed data has strengths that could overcome some of the weaknesses of interview data. Another thing that I thought of from an industrial hygienist viewpoint, you have temporary threshold changes in hearing. So if an individual was exposed to high levels of noise before they went into their audiogram, and it wasn't accounted for, that could lead to some results that aren't indicative of what the actual population's results should be. And they did kind of look at that and not look at it, but they tried to control for it almost in this case. If you remember in the article, it says that the study was occurring during the 2 days of rest before they were going to have their race. So hopefully they're limiting the riding that they're doing before they were going to go for their race, but we don't know. There's no data in the study that suggests that they ask questions about, were you exposed to high levels of noise? Were you riding yesterday? Because temporary threshold shifts can last from an hour to a week. So the fact that they didn't account for that is definitely a weakness that they probably should have thought of. It doesn't include none of this data, and it wasn't part of their idea to try to measure a time weighted average for the amount of noise these riders are exposed to. But since their title suggests, that's one thing we'll talk about in a little bit, is I think the title is a little bit deceiving. It says hearing loss in Grand Prix motorcyclists, occupational hazard or sports injury. It definitely puts off the idea that automatically this is what it has to be. It's one of these two things that could be causing this, but with no data actually showing the noise exposure from what these motorcyclists are doing during their day, I don't think that I feel comfortable with the suggestion that they're making that it is one of these two things. The noise-induced hearing loss is due to the riding of the motorcycle, because it could be many things. And yeah, so that gets all the way down to the bottom of that one. Any questions so far, by the way? So these results, I think that they're interesting for me because I am doing research right now at work for my master's thesis. I work for the Rio Tinto Kennecott smelter, and they approached me about doing some sound mapping around there, just turned it in my master's thesis. So noise is always interesting to me, and hearing about populations that maybe are overlooked helps me to think about the populations at work that may be overlooked. Might be something that you guys should consider as well as you're doing your research or going to your jobs. In terms of some other applications, some other learning opportunities from this study, I think that assumptions should be clearly stated as assumptions in research. This study, the assumptions that they made definitely felt like they were made as statements of fact rather than assumptions that they were making. And I think that we should avoid that as researchers. Anybody doing your thesis or your project, your dissertation, just keep that in mind as you're writing. State that an assumption is an assumption. I also think that research should have a clear objective, and the results and discussion should aim to answer this question. That was something that I found not super clear in this study. The introduction didn't do a very good job at stating the objective of the overall study, in my opinion. And the results and discussion should tie back to that objective statement that you make. Oftentimes in research, you'll see them make a general objectives claim or purpose claim, and it didn't do a very good job of that here. And so that brings us to some group discussion questions I had for you guys that I have found myself thinking about, kind of the more meta ideas, less about this study and more about what it represents as a whole in research. Do you think it is safe to assume from these results that motorcycle riding is negatively impacting hearing? What do you guys think?
Just, I wonder if I can ask a question.
Yeah.
Because they were looking at the wind blowing through your ears. How loud are these engines?
That's one of my
I was wondering if there'd be a value to look at the mechanics, so I don't know if they're riding as well.
Mhm.
And then just a secondary comment, you mentioned assumptions. I found it interesting that in their conclusions, they kept saying without doubt, no doubt. I thought those were very powerful statements that I think it'd be hard to say in almost any study, as opposed to saying we've demonstrated this, we have confidence levels, as opposed to saying no doubt. I'm surprised we have research that comes with no doubt. But my real question was, what are the other exposures, not just with riding, but and then also, I'm assuming these guys are helmeted. I don't know the sport. How does that alter the exposure to the decibels that they're having. They said these are the decibels with the wind. I'm assuming that's an unhelmeted person. So I just had some questions about the exposures and whether a control group could be mechanics to see what their hearing is. Not so much that I wouldn't be surprised if they had it, but they seem to be attributing this all to just the speed and the wind.
Yeah, thanks for bringing that up. Those are things that I was thinking about as well. If their purpose and claims at the beginning had been more clearly stated, I don't think we would have to worry about that as much, because those are some points that I thought of in my mind as well. When really the main objective of their research, according to their methods, rather than what they said exactly, was that they wanted to show that there was a higher prevalence of noise-induced hearing loss in these motorcyclists, rather than pinpoint exactly what it was that was causing the noise-induced hearing loss. But I think they made some assumptions due to the fact that prevalence of noise-induced hearing loss was high in these workers. So thanks for bringing that up. I think that had they been a little more clear in their research, I think some of our questions could be eliminated and we could recognize the scope a little bit easier of what they were trying to do. So what do you guys think though? Is it safe to assume that the results are indicating that motorcycle riding is associated with noise-induced hearing loss?
I think yes, probably, but one way that they could improve their study is by doing it over time instead of just to see if there is a threshold STS. Because usually in like the workplace, you do an annual audiogram to see if there has been a change. And here it's just like comparing it to that other group. Yes, there is a change, but for you personally, is there a standard threshold shift between like this race and the next year's race or whatever? And so I think that would help prove their point of if it's actually impacting their hearing or not, is by doing more than just one audiogram.
Yeah, thank you. Any other thoughts? I agree with them. I personally think these results are indicative that noise-induced hearing loss probably is connected in some way to motorcycle racing. And I think that's a difficult hurdle for us to jump sometimes in research, is we need results that are very indicative, methods that are very precise about the study that we're using to be able to say with high confidence that something is there, when sometimes it's just like an interesting thing, I think, in research. I think that sometimes in some ways it's important to be very precise with our methodology, but sometimes I think we can go overboard. If I were to say that I don't think that noise-induced hearing loss comes from motorcyclists and that this research means nothing, I think that would be too far in the other direction. In other words, there's somewhere in the middle where we have to recognize that research like this may be of value, which is more of what I was trying to get at. I'm reading this question now, second question, and I think I needed to reword that one. I think the question that I wanted to get to that leads into is, what kind of value do you find in this kind of research? What are some things that you think are valuable about it?
Kind of a research would be really good to do in a series. So if this is your first part of a series, if you're going to compare this one and then the same drivers another one and have it start, I think it would be really useful. Other than that, just by itself, it doesn't seem like it's too strong by itself, you know.
Thank you. So kind of as a stepping stone,
Right.
You see it as more of the preliminary research that could lead to something that would evolve the study. So what are some future studies that you guys would do if you were using this as a stepping stone? Are there any other questions you have in mind?
As far as like future research in this type of area, kind of from like an engineering standpoint, it said that where does it say the noise arises not from the machinery from which adequate controls exist, but from turbulent flow around the rider's helmet. And this was in 1992, I think. I'd be curious to see how much like the design of motorcycle helmets has changed since that point in time, if they're able to create a more laminar flow to get away from those high frequencies where it can damage their ears. So I think that's maybe a potential for something to look at in the future.
Yeah, really good point. So we see, yeah, it's used as a stepping stone for engineering. I wasn't even thinking of that at all. More of an IH perspective for me, but super cool. Thank you. Any other thoughts? Any other questions you guys have?
So this is maybe a question to some of the people in the room who've been at this a long time. Do you think a paper like this would get published today? And if not, how have the standards of the discipline changed? I'm staring at you, Kurt.
Yeah, everybody's that's what happens when you have lots of weight here. I don't. You're gonna have to have more details in this day and age to get something published, and I think it's probably gonna have to have it has to tilt the windmill, not on one hand, in terms of a higher quality journal. Now, in this day and age, there's a proliferation of, you pay for the article to be published journals. So in a way, it would be easier to get it published, ironically. But where is there now a question? I'm not sure that answered your question. In terms of a higher tier journal, no. I think you'd have to have more details and that sort of thing. In this day and age, so you've also got, there's all kinds of other considerations. You'd have to know more about the exposure, I think, than just saying, oh, by the way, in the introduction, it might be this level of exposure.
Yeah.
There's a few rambling thoughts.
Thank you. And one final question, something that, again, I'd mentioned it earlier, but I think one question in my mind was the title of this study. It just felt almost deceiving in some ways. What are some better titles that we could give this study? If you guys are looking at their methods, what they were actually trying to research, what are some things that you guys would title it off the top of your heads?
Loud noises are bad for hearing.
Yes.
An observation of the effect of noise.
Yeah.
It's basically all they did is practically an observation.
I was thinking of their end statistics that they calculated for us and what they were looking at specifically. One title I thought of was the prevalence of noise-induced hearing loss in Grand Prix motorcyclists. I think that feels more indicative of what they did. I don't know that in the end, if they really answered the question of their title, hearing loss in Grand Prix motorcyclists, occupational hazard or sports injury, it didn't quite hit it for me. So those are some thoughts that I had about this study, some things that I think you ought to think about in your future research endeavors, and some things that you should look at in your future studies that you're reading as you prepare for yours.
How did you get interested in this article or find it
So as I mentioned earlier, I'm really intrigued by noise-induced hearing loss. I do industrial hygiene, so we deal with a lot of problems with it out at the Rio Tinto smelter. So I was just looking at noise-induced hearing loss, and I think that was literally just what I searched in journals was noise-induced hearing loss, and I filtered through a bunch of articles. I wanted to do one that maybe had some methods that were in question to help strengthen my abilities as I looked at it, like, okay, what angles am I not seeing that I could recognize in somebody else's research that could help me to make sure that I don't make the same mistakes. So it fit those categories for me. But yeah, any other questions?
So looking at figure 3, everybody talks about the notch. It's the folks up to date that you think about a 4,000 to 6,000 notch, which is really present in opiates in the 50th percentage study population. My question is, does it affect the other values at other decibels at different versions? In other words, what do the audiograms look like? Is it only the notch?
If I'm understanding you correctly, you're asking about would their hearing loss at those specific frequencies affect the hearing loss they're experiencing at the before frequencies? The lower?
Sort of. Are the values, I'll make a different question. Are the values of normal at 250, 500, 1,000, for example? Are they different between the two groups? Yeah, I would say they are too.
Yeah.
You gotta kind of look at the 50th here. But, so it's not just a notch. And remember that your speaking level, decibel levels are approximately, well, no, roughly.
60 or 70.
500 to 2,000, 3,000, 4,000, not above that. It's your speaking range. Okay, so in short, the notch is not that important for a typical speaking range. But the problem is that's also depressed across the various hertz.
Yeah,
Greater
great point.
teaching point, but it's sort of a important teaching point.
Yeah, great point. Thank you for that. Important to recognize it wasn't just those higher level frequencies where we saw the differences. Great, thank you. That's it for me.
We'll be back this time and play this obviously next week. And then 2 weeks from today, we've got the Paul Richard Collective Theories, Dr. Gidley, Industrial Organizational Psychology and the State, I believe. Will be here. I think you all should have gotten an invite. I don't know that you have not gotten one, let me know, and I'll issue over one. But for that,
I got 50% of
Oh, in my class.